Today we'll be looking at OneTick Map-Reduce, a Hadoop-based solution that combines OneTick's analytical engine with the MapReduce computational model, and we'll be talking about how you can use it to perform distributed computations over large volumes of financial tick data. My name is Hugh Heinzen, and I'll be your host today, and we're joined by three panelists. First, we have Louis Lobus, the Director of Solutions for OMD. Louis focuses his efforts on developing and explaining how OneMarketData clients can leverage the technology you're going to see today to improve the efficiency of their trading operations and increase profitability. You may be familiar with Louis from some of his writings. He's a frequent contributor to Advanced Trading, Tab Forum, Trading Screen, and many other publications. Before joining OneMarketData in 2010, he was the Chief Architect and Fellow for Progress Software and Apama, where he concentrated his efforts on the Apama CEP platform. We also have Kirill Karpelson, the Head of Client Services for OneMarketData. Kirill has been working on Wall Street since completing a graduate degree in Information Systems at NYU. He spent 15 years at Morgan Stanley in various technology roles and joined OneMarketData in 2011, where he runs the Client Services team, which includes support and premium support. And we also have on hand to help us answer questions when we take questions towards the end of this webinar, Narek Sarabekian. And he is going to, again, help us answer questions when we take those questions from the audience at the end of the webinar. Narek joined OMD in 2011, and he coordinates the development of the company's big data projects. And with that, I'm going to turn it over to Louis to take it away.
Hello, everyone. Thank you, Hugh, for that introduction, and welcome everyone to our discussion today on OneTick's integration with Hadoop and MapReduce. So just to start off, right, OneTick Map-Reduce is a Hadoop-based solution combining OneTick's analytical engine with the MapReduce computational model that can be used to perform distributed computations over large volumes of tick data. This webinar, while very technical in nature, is not a tutorial on Hadoop or OneTick for that matter, but an overview of the complementary nature of the two products and how we've done the integration. Nonetheless, just as an introduction, and to ensure the purpose of this webinar is clear, I'll begin with an overview of both Hadoop and OneTick. Hadoop software is a framework that allows for the distributed parallel processing of large data sets across clusters of computers. Its strength lies in its ability to scale and parallelize across many servers that don't share memory or disk. There are two key functional components within Hadoop: the storage of data on a file system, such as HDFS, and a framework called MapReduce for running parallel computations on this data. MapReduce is about moving computation to the data and not moving data to the compute nodes. Its strength lies in the ability to divide a single large data processing job into smaller tasks. A task is spread across multiple nodes and runs simultaneously. This is the map step. The reduce phase combines the results back together. There is also a resource manager called Yarn for handling the delegation of resources across nodes for MapReduce jobs. The OneTick technology complements OneTick. The Hadoop technology complements OneTick very well, and we'll go much deeper into all of this. But first, let me introduce OneTick a little bit. OneTick is a distributed tick data management system, specifically a time series database, a query analytics engine, software tools for building those queries, and APIs for interfacing with common programming languages. The query computation engine includes a library of functional data processors, which we call event processors. Those are used for building OneTick queries. Those queries are constructed as a series of nodes using a visual editor. Each node is one of these data processors, and linked together they form a query. Queries are user applications of OneTick, following a streaming data programming model as data flows from node to node. Along the way, data can be consolidated, filtered, aggregated, or otherwise enriched. The assembled nodes of a graph query are applications for quants to research markets, from microstructure and econometric analysis to create and test algorithmic trade logic, for trade surveillance pattern detection and order flow transaction cost analysis. Through the variety of OneTick APIs in Python, C#, Java, and C++, queries can be executed and results consumed and processed. The OneTick architecture allows for databases to be spread across multiple physical machines, and queries are easily parallelized for distributed computation. And because of this internal architecture, the integration with Hadoop is a very natural extension. Once you have a general understanding of Hadoop, MapReduce, and OneTick, that of course leads to the question, what is OneTick MapReduce? It is a OneTick query execution module based on the Hadoop MapReduce computational model. It allows OneTick databases to live within the Hadoop file system and queries to be parallelized and distributed in a Hadoop cluster. OneTick queries are inherently parallelized, making it a natural fit into the task model of MapReduce. This splitting or parallelization is by symbol or groups of symbols, which can be further optimized by locality awareness, or splitting the job such that tasks are routed to nodes in the cluster having the symbol's data. That's the market history the task is querying. OneTick has its own internal resource management for distributed computation of a query to multiple OneTick database servers. Therefore, the integration to Hadoop is both natural and complementary. We've built OneTick MapReduce with a few key objectives in mind: to make best use of what Hadoop has to offer, together with what OneTick already supports natively for distributed computation across commodity server hardware and storage. Hadoop, MapReduce, and OneTick integration offers you a choice for scaling and parallelization to achieve query optimization. And that integration is both modular in design and easily configurable. OneTick MapReduce allows you to choose a job client to execute a query that can be Hadoop Yarn or OneTick's own native module. This is set as a query configuration value, and we'll demonstrate that shortly. This overview of Hadoop, MapReduce, and OneTick and their distributed computational models is not intended to pass judgment on the benefits or the features or be a performance comparison, but rather to offer users a choice, one that allows you to leverage the best option for your unique requirements, including business needs, technical, and commercial factors.
Okay, and with that, we're going to turn it back over, I believe, to Kirill now.
All right. Hello, everyone. My name is Kirill Karpelson, and we're going to talk about the technical details of OneTick Hadoop integration. We will start by looking at the major Hadoop components. Those are the Hadoop Distributed File System, HDFS, which can actually be replaced because we're trying to do our design, make it modular, by other file systems such as an arguably more advanced MapRFS or regular file systems set up on SAN, on NAS, or even Amazon S3 or EFS. Another component is splitter. It's a component that splits the large query into chunks called splits, so that each chunk will get executed on a specific Hadoop node. And finally, there is a job client / resource manager component that dispatches the map tasks between the nodes, where each task executes a particular split. We will now do a deeper dive into each of those components. As I said before, the data storage component of the Hadoop architecture is implemented as file system. It could be either Hadoop's native HDFS or MapRFS, or a file or block level storage such as SAN or NAS on your own hardware, or it could be based on a cloud such as Amazon Cloud, S3 or EFS storage, or any other cloud infrastructure. Now let's talk about the splitter. As I said before, it splits the original OneTick query into smaller tasks. But we can also make the splitting locality aware. The interesting thing is that we made the degree of locality awareness highly configurable. There are three settings: HDFS, which means that the splitter will adhere closely to how the data is distributed among the nodes. Data size, where we ensure that we process the same amount of data, but not necessarily the same number of symbols per node. And empty, which splits the symbols evenly across the nodes, just like OneTick distributed computation works. The third component of the Hadoop architecture we're going to look at is job client. It decides which node works on which split. To do that, it can take into account both the CPU load on each node as well as the data distribution based on the data locality policy. We support the following job clients. The Apache Yarn, which comes with Hadoop. It doesn't require us to have OneTick servers running on each node, but we do, however, need to have OneTick distribution installed on each node. We have also integrated OneTick with Spark, and therefore support Spark job client running in standalone mode. Note, however, that Spark job client can also use Yarn or Apache Mesos as alternatives. We have also written a OneTick job client, or we call it native job client. It has configurable load balancing policy, either round robin or server load based, and it even allows us to assign weight to data locality awareness from 0, which means ignore data locality, to 1, which means ignore the server load. Now let's talk about query execution. First of all, as Louis explained earlier, OneTick query is a collection of analytics applied to multiple streams of financial data, for example, with multiple symbols at a time. The Hadoop cluster will be set up in a way that we have OneTick software installed on each of the nodes, optionally running the tick server on each node. Each node will also have a local license, OneTick license for query processing, automatically obtained from the main tick server. Query gets split amongst the nodes and gets executed on each node by the bytecode supplied by the tick server. Bytecode is actually a OneTick API jar file that knows how to run the serialized OneTick query. Now let's see how we would need to set things up. As I said before, each node will have to have OneTick software installed or have it accessible via shared storage. Each node will use the same set of config files. The cluster can be either deployed on private infrastructure or on Amazon or any other cloud service. And OneTick distribution will include all necessary scripts to set things up. Cluster maintenance scripts, Fuse driver to mount HDFS, and Amazon deployment scripts. We also need a bunch of environment variables to be set up that specify the mount point, config, and install directories. And in order to control data locality, job client type, split size, and other variables, we use OneTick query properties. Finally, here are the Hadoop and Spark versions and flavors that we have looked at. We're also working on integrating secure Hadoop with Kerberos authentication. And now to the demo. I will show a quick overview of our setup and configuration, and we'll run a couple of very simple and easy to understand OneTick queries that nonetheless illustrate very well the OneTick Hadoop integration. So in this particular setup, we have 11 nodes. The main one called Hadoop 000 and 10 additional ones called Hadoop 001 through Hadoop 010. We're now logged on to the Hadoop 000. So first of all, we have the main tick server running. Each node also has its own tick server running. As I mentioned before, it's not a requirement for Apache Yarn job client, but it is a requirement for OneTick native job client, so that's why I have them running as well. A few things we might want to check. First of all, let's see if HDFS is working. To do that, we have this web interface into HDFS. As you can see, it shows us a bunch of Hadoop nodes here, and you see this last contact time that shows, how many seconds ago it contacted each, and as I refresh this, it's kind of updating, so that's important to see that the file system is actually live. Another thing I wanted to show you is if we browse the file system, go into our data folder and look at, we have a bunch of databases loaded here. Let's look at one of them, SIAC. We only have one day loaded for that database. And these are actual files. Now, notice a couple of things. First of all, we have block size of 128 megabytes. And if I click on this data unassigned file, which is the biggest file in this directory, you will see there is a whole bunch of blocks, 133 overall. And as I go through different blocks, it tells me the distribution of that block across multiple Hadoop nodes, right? So that tells us that each block is actually replicated 4 times, so in this particular configuration. So this adds to the resiliency of the whole setup. So if one node goes down, there are 3 others that still contain the same data, so it could still function. The next thing to check, let's go back to my terminal. The next thing to check would be to see if our fuse driver is up. So I think I ran this command before, but let's just double check this. Yeah, so this is where HDFS is mounted. So we can make sure that it's up and running. There is also, we have a little script that we can run. Yeah, this one, check fuse DFS. So it basically does SSH to every node and checks the same thing, checks the whether this mount point is present on each node. Let's go back. Okay. So that's good. Now, next to check would be next thing to check would be to make sure that Yarn and Spark are up and running. So we can use JPS, Java PS command. So we can see that Yarn Node Manager is up and running, and this one, Yarn Resource Manager is up and running. Also, our Spark Master is up and running. So looks like, you know, things are functional. We also have a couple of web interfaces into this, so we could check the these 2 websites. For this one is for Spark Master. This is for different applications that are running. So seems like, you know, the system is responsive and everything. Very good. Now, one last thing we might want to check, you know, if this were a new installation, is to see whether OneTick is actually installed on each node and whether tick servers are up and running. You can do that. We, you know, have similar scripts to the check fuse driver where we SSH to each node and make sure that the installer is there and tick servers are up and running. Now, let's look at OneTick GUI, OneTick Query Editor. We call it GUI internally, but it really is an environment that allows you to create OneTick queries, test them, debug them, and see the results. So let's look first at, actually before I run this, let me show you one more config file. This is important. The file is a little XML configuration file which shows the information about the node. So it's called MapReduce clusters.xml. So this file contains a bunch of settings and information about the node, the Hadoop cluster. Specifically, I want to focus your attention on the following parameters. So first of all, job client Hadoop. So that's the default job client. Let's look at this one, data locality. That's the next important one. At the moment, it's set to empty, so that means that we're using, we're just splitting symbols equally, and we're using OneTick native distribution mechanism. Data locality ratio 0.5 and load balancing policy server load weighted. So we'll try and play with these 2 parameters later on and see how they affect the distribution of the results. Okay, so let's look at a very simple query. It's called trade count. What it simply does is it computes the number of trade ticks for the given time interval for a bunch of symbols. Here are the symbols. There are 100 of them. I also add a node that tells me on which Hadoop cluster node this particular computation, this particular symbol was processed. So if we run this, you can see, so this is the trade count for all these different symbols. This column is Hadoop node, and you can see that, these 10 symbols were processed on Hadoop 8, then Hadoop 9, Hadoop 4, 0, 4 again, 7, 0, 10. So you basically see how things are distributed amongst different nodes. All right, the next thing I want to do is go to this file, to the MapReduce clusters XML, and change the policy to HDFS and data locality policy. And I'll also change the ratio to 1.0. What this means is ignore the server load completely. Only use the data locality policy, which is kind of justified in this case because we have those 10 nodes which are not doing anything other than just, tick servers are idling there. So I want to make sure that we, that we only use the locality to process the ticks. So first I want to stop the tick server, and then I start it. Okay. And let's see, go back here. So let's run this. Let's see what happens. Okay. So you see that the distribution is different now, that actually, I don't know, maybe we could say that, let's say, node 5 seems to be favored because it just so happens that most of those symbols happen to live on node 5. So that's the point of this exercise, to basically see that the distribution is different. Very good. Let's look at the next query, which I have right here. Let's see what it does first. So this query computes bars, right? So again, I start with the trade ticks, and then I use this event processor called compute, which computes a whole bunch of different metrics. So it computes the open, high, low, close, VWAP, return, volume, and number of ticks. The interval is 300 seconds, that's 5 minutes. So we basically build 5-minute bars. Then I filter ticks to make sure I only get, ticks between 9:30 and 4 p.m. in Eastern time zone. And I also filter out the bars that are empty, that have number of ticks equal to 0. So, I leave only those that have non-zero number of ticks. And finally, I add the node as well. So we're going to use the native job client initially. So let's run this. Okay, so this is the result. So here, if we click on the first symbol, we only get the ticks for the bars for the first symbol, A. So you can see that this symbol all gets processed on the same node, Hadoop 1. And as we sort of go through different symbols, the nodes differ. You see some symbols are not ticking as frequently, so there are fewer bars, because remember, we filter out those that have 0 bars. So Hadoop 6 seems to be popular. Okay, one last thing I wanted to try is to just show that we have integrated Spark as well. Spark. So let's try that. It takes probably a little bit longer, but again, this demo is not really a demonstration of our of performance in any way. It's a demonstration of functionality. For performance, we could do something else. So okay, so yeah, so we got here. Let me do a similar type of scroll, so you could see that some of the executions happen on one node and others on another. I think at this point here we are ready for some questions.
Okay, fantastic. We have a number of questions. Please keep them coming. Please don't hesitate to type them into that Q&A window. Let's take this first question about the kind of the granularity in terms of time. How real time are the time series analytics? How real time are the time series analytics that you've been showing?
Lou, you want to answer that, or should I?
Yeah. Why don't you? Well, Narek, why don't you take that one? And
Sure. So the latencies, they really depend on the job client and resource management configuration. So Kirill has introduced three types of job clients. We have a Hadoop job client, Spark job client, a native job client, something you could call a OneTick job client as well. So we were observing with Apache Yarn latencies up to 15 seconds. So the initial latency that we've seen was about 15 seconds when you start actually submitting the job, and it takes about that time till you get your map task starting to execute on the cluster. However, using a Spark configuration as a job client and resource management configuration pair, you have a more interactive setup when queries usually take from 1 to 2 seconds to run. So the initial latency is less, and therefore the queries are more interactive. You have an opportunity to run more interactive queries here. And third option is to go with the native job client, where, as you've seen with the demo, the latencies that we're observing are sub-millisecond, which means that in theory you could run real-time queries here, also involving in-memory database queries. But this is something that OneTick's vanilla OneTick also can support very well with parallelized computations. So this is another opportunity for you, I think, to really consider the benefits of using pure OneTick versus using something like big data, Hadoop or Spark setups, where they are really better oriented for batch processing versus what OneTick can do in terms of real-time analysis, real-time series analysis. So I think that's pretty much it. So it's not very real-time, but you can switch, because of the modular configurable nature of OneTick Map-Reduce, you can switch to a real-time mode and try to make best use of OneTick's real-time capabilities here. So I hope that answers your question.
Okay, the question is, which Hadoop vendors does OneMarketData work with?
So we currently tested our OneTick Map-Reduce module with Apache's default open source distribution of Hadoop. We've also tried doing some performance tests with MapR. In some initial stages, we also had tests with Cloudera, but you're not restricted to any particular Hadoop distribution, because we are making sure that the features that we use are universal, that they don't change from one distribution to another. However, so using something like a MapR distributed file system will give you huge benefits over other distributions, probably because of the more sophisticated, more high-performance nature of their distributed file system implementation.
Okay. All right, good. And while we're on a platform question, we have a question regarding cloud servers. Can we use Microsoft Azure instead of Amazon EC2?
Yeah, the answer is yes. We're not limited to any public cloud infrastructure servers. However, we do ship a deployment script that makes it easier to deploy on Amazon EMR. And apart from that, OneTick also comes with an administration monitoring module that has support and has actually nice GUI and support for deploying virtual machines using the EC2 interface. But apart from that, the settlement configuration is not limited to only Amazon virtualization environments. So yes, you can use Microsoft Azure as well.
Okay. All right, and sort of a related question, in terms of where, in this demo that we're seeing right now, where are you running that client software? Is that running on your local machine, or is that running out of the cloud?
Yes.
Yeah.
Maybe
Go ahead.
Carol can answer that question.
Yeah, it's running on my local laptop.
Okay. But
Yeah.
you could run it out of the cloud if you wanted
Yeah,
to?
it could be exactly. It could be anywhere as long as there is connectivity between the client and the server.
Okay. All
Yeah.
right. This is a good question. Market data is quite structured, but as I understand it, MapReduce benefits is best used with unstructured data. The question is, what kind of financial information do you consider to be unstructured and that you can take advantage of using this OneTick and Hadoop integration?
Hey, maybe I'll take that one. This is Louis.
Oh, yeah.
That's not an uncommon question we hear, that people want to look at unstructured data, and that really falls into two buckets. That would just be sentimentized content, either from social media, which we've done, like Twitter feed, or news headlines. And so that data could be in its sort of amorphous state, unstructured, or it could be semi-structured, which is common for like headlines. So and we often have been asked about integration with those and using conjunction with structured data. And obviously that structured data in our world is essentially trades, quotes, and order book data, just to essentially look at market movements relative to news announcements. We often get requests for that. And quite honestly, from a trade surveillance point of view, that is the foundation for building insider trading pattern detection. So it isn't just about the structured content. It's about how the market may move relative to external factors that could be reported through those unstructured sources such as news, media, and social media data. But those are the two main things I think that we often see, and sure that you could easily combine these two within this MapReduce infrastructure.
Okay, excellent. You talked a bit about Spark. Why would someone prefer using Spark over Hadoop or Hadoop over Spark? What circumstances would lead one to choose one over the other?
Yeah, so the short answer is that Spark provides more interactivity compared to Hadoop's Apache YARN module. But as a matter of fact, Spark can be run in three separate modes, which is the standalone mode, the Apache YARN mode, and the Apache Mesos mode, which means that the Apache Spark job plan can turn into something that also makes use of a cluster management module like Apache YARN. So when comparing Hadoop and Spark, we're going to look at which of these two job plans and resource management configuration pairs provide more opportunities for in-memory data querying. And Spark has proved to be superior to Hadoop from that perspective. If you have queries that are more interactive, require in-memory data queries, that you probably should go with Spark because Hadoop is more oriented towards, large batch data processing, which is probably stored on HDFS, and most of the runs are cold, which means that you have to look at the file system. You have to have cold read and read the data from the underlying directly attached storages into the memory. So yeah, Spark is more interactive compared to...
All right. Well, you touched on file systems, and that brings up another question. What is the best file system to pick for this type of integration, OneTick and Hadoop? HDFS, MAP, RFS. What do you think is the best?
Right. So HDFS, what in essence HDFS provides is a very low-cost method for achieving a fault-tolerant and easy to scale storage solution. So usually people really recommend using directly attached storages with HDFS. So you're going to have to get a lot of commodity hardware and get them together into one cluster and have that set up as and configured as a distributed file system. But in some cases, when using this sophisticated distributed file system, users may see that the read or write operation, the I/O operations are about from 5 to 10 times slower than on the same hardware, which means that if you use a lot more cold queries, if you're not consistent with the types of queries that you use or the data that you're querying, you better go with something that can provide very high performance I/O operations. But if you're consistent with the type of queries and with the data that you query from your cluster, you can have a pretty good performance having your HDFS set up and making use of caching features available with HDFS too. And with HDFS, there were some studies that shown that you can have a very good performance with the same value price compared to what you could get with the enterprise storage solution. So the short answer is, if you want a low cost and in some cases a very efficient storage solution, especially when you have especially when you're consistent with the queries that you use, so go with this DFS. Otherwise, you can consider having some NAS, SAN storage options. But the general recommendation is not to really mix HDFS with SN, because what you're really benefiting from Hadoop and MapReduce is the idiom that the computation moves to data. And when you don't have that data locality awareness, when you're starting actually running map tasks on a particular node, you're basically, if you're using an NAS setup under the hood with the HDFS, you're basically opening network connections for each map task execution, which really, it's not the best use case with Hadoop. So not mix NAS, SAN with HDFS. Use them separately, but if you use HDFS, use them with directly attached storages. That is the general best case scenario.
Okay, very good. And this is sort of a related question. Is the data being stored in binary format or text in HDFS?
Yes, so we use the standard OneTick archive format, which is a binary format. And related to the question that we had previously about the structure of the data, we actually have a process called normalization, which actually structures the data, which is more efficient for OneTick queries to efficiently really query the data. So yes, we have a binary format. This is our native format, and we use that format to store on the HDFS.
Okay. All right, let's take two more questions and then wrap it up for the day. Actually, I'm going to combine two questions into one, and this regards the Hadoop nodes that you were demonstrating and discussing. What are the number of nodes that you require to run the type of application you were describing? And are these nodes physical servers themselves? What exactly constitutes a node? So two questions, how many nodes, and exactly what are they?
So I suppose the question is about the current setup that we have here. The current setup is a set of virtual machines running inside a host server machine. So this is not a typical high-performance setup, but it's something that we have that we can run and get some functional results. This is not intended for high-performance testing, the setup that we have here. So we have around 11 nodes, if I remember correctly, that run inside a Linux host machine here. Yeah.
I just want to reiterate that this whole setup was designed for functional testing rather than performance. So don't ignore the performance numbers on this particular setup.
Okay, but in a real-world environment, you would set it up quite differently than what you have here for the demonstration.
Right.
Absolutely.
You will have actual, physical hardware most likely if that's what you chose, or you could have, Amazon, for example, nodes. It depends. The whole purpose is that you use, the whole point of, I guess, MapReduce is that you use commodity hardware, which is cheaper, but you have many more machines like that, and that way you can solve large problems.
I see. Okay. And we'll make this our final question. I think it's quite a good one. Is this solution, this combination of OneTick with Hadoop, really best suited for pure quantitative fundamental analysis or algo trading, or would it also make sense to use it, say, in portfolio and risk management applications?
Yeah, maybe maybe Louis would take on that question.
Yeah, sure. I'll take. It's a good question. I think the trying to divorce any real targeted. Is it good for one use case or is it good for another use case? I think it's really good for, as Kirill mentioned, if you've got sort of large problem sets that want to look at large amounts of data, and whether the data is either very dense, for example, like option depth of book is extraordinarily dense, or it's very compute intensive, like doing a Monte Carlo type analysis, risk analysis. Just given the enormous compute requirement, I think this sort of distributed computational model to be able to leverage inexpensive or virtualized server hardware allows you to solve those kind of problems. Problems that, just going back even a few years ago were completely intractable other than an overnight batch, right? So you would set it up and you'd go home and then you'd come back the next day. And now this problem space is turned from that old-style overnight batch almost into interactive, again, depending on the depth of analysis, but by and large, I think this is really focused at any use case, any scenario where that involves an enormous amount of data, either in terms of history itself or density of data, or the combination of the two, along with the parallelizable nature of the algorithm, and I think absolutely can do any of these.
Fantastic. Okay, very good. This session has been recorded, and we will make this recording available on the website within the next couple of days. So please watch for that. Everybody who registered will get an email with a link to that recording, but it'll also be available through the OneTick website. Please check that out. Thanks very much, Grace, for a great presentation. Really interesting. A lot of great questions from the audience as well. Really interesting demonstration of some very interesting technology. Thanks again to everyone for attending. Please watch this space for our next webinar. The topic's not determined yet, but we will be holding another one relatively soon. Please stay tuned.